Hello children, welcome back. Today we are going to see Chapter 4 States of Matter Part 4. So children, by now we know that in an atom, electrons revolve around the nucleus while protons and neutrons are inside the nucleus. The question is, how do electrons revolve? Do they move randomly or do they follow a specific route? How are they arranged? The answer to this is electronic configuration. Rules given by Bohr-Bury for distribution of electrons are these orbits or shells are represented by the letter K, L, M, N or the numbers 1, 2, 3, 4 and so on. The maximum number of electrons present in the shell is given by the formula 2n square, where n represents the number of shell, whether K shell, L shell, M shell or N shell. The first orbit or K shell will have 2 electrons, that is, the number of shell is 1, so 2n square will be equal to 2. The second shell will have 2 multiplied by 2 square, which is equal to 8 electrons. The third shell will have 18 electrons, fourth shell will have 32 electrons and so on. The maximum number of electrons which can be accommodated in the outermost orbit is 8. But remember children, electrons are not accommodated in a given shell unless the inner shell are filled. That is, the first shell will be filled, that is K shell, then L shell, then M shell, then N shell and so on. Then what is valency? An element's valency is determined by the number of electrons in its outer shell. Hence, the number of valence electron obtained from the electronic configuration of the element gives the valency, that is, the number of electrons lost, gained or shared by the element to attain the noble gas configuration, that is, duplet and or octet. So now we have understood what is valency, that is the capacity of an element to combine. Now the valency of an element is indicated by a specific number. It is the number of chemical bonds formed by one atom of that element with other atoms. In 20th century, the relationship of the valency of an element with its electronic configuration was recognized. Now we shall take the example of sodium chloride. Now as you can see, the electronic configuration of sodium is 281 and the electronic configuration of chlorine atom is 287. Now as we know that the number of electrons they lose, gain or share to attain noble gas configuration. So here sodium atom has 1 electron in the outermost orbit. Similarly, chlorine atom has 7 electrons in the outermost orbit. So sodium atom gives away 1 electron and a cation of sodium is formed. Hence, the valency of sodium is 1. So, it gives away 1 electrons. Whereas a chlorine atom takes up 1 electron, as you know, it has 7 electrons in the outermost orbit. So, it takes 1 electron and forms an anion of chloride. And thus, the valency of chlorine is also 1. After the give and take of electrons, is over the electronic configuration of both the resulting ions has a complete octet, that is sodium 2,8 and chlorine 2,8,8. Due to the attraction between the unit but opposite charges on the two ions, one chemical bond is formed between sodium and chlorine, and the compound formed is sodium chloride. Thus, a sodium atom has the capacity to give away one electron, while a chlorine atom has the capacity to take up one electron. That means the valency of both the elements is 1. So, we can define valency as the number of electrons that an atom of an element gives away or takes up while forming an ionic bond is called the valency of that element. The number of electrons that are given away or taken up is always a whole number. Therefore, valency is always a whole number. Under different conditions, the atoms of some elements give away or take up different numbers of electrons. In such cases, those elements they exhibit more than one valency, and this property of element is called variable valency. Now you can see in the chart variable valency of different elements. So you can just see there are two charts. Towards the left hand side you can see the valency of different elements, and right hand side you can see the variable valency of different elements. One element shows two valencies. For example, copper, it shows valency of 1 and 2. Mercury, which shows the valency of 1 and 2. Iron, which shows the valency of 2 and 3. So it forms cuprous and cupric ions. Mercury forms mercurous or mercuric ions. Iron forms ferrous or ferric ions. So it depends upon how many electrons they are losing. For example, cuprous 1 electrons, the loss of 1 electron, and cupric ion is formed when there is loss of 2 electrons. Similar way, ferrous when it gives away 2 electrons, ferric ion when it loses 3 electrons. So there are two valencies, 2 and 3. So hence you can see in the chart variable valency of different elements given. As we know, in compound, group of atoms of same element or different elements combine chemically that behave as a single unit. Whereas compounds with ionic bonds have two constituents. These are cation, positively charged ion, and anion, negatively charged ion. They take part independently in chemical reactions and are therefore called radicals. As you can see, sodium hydroxide, sodium is a positively charged ion, that is, it is cation, whereas a hydroxide, that is, it is a negatively charged ion, that is anion. So therefore they are called as radicals because they take part independently in chemical reactions. Now it is seen that different bases such as sodium hydroxide, potassium hydroxide are formed when various cationic radicals are paired with the anionic radical, that is hydroxide. Hence the cationic radicals are also called as basic radicals. Different bases are distinguished from each other by the basic radicals in them. On the other hand, different acids such as hydrogen chloride, hydrogen bromide are formed when various anionic radicals are paired with the cationic radical H+. Therefore, the anionic radicals are called acidic radicals. Basic radicals are formed by removal of electrons from the atoms of metals. whereas the acidic radicals are formed by adding electrons to the atoms of non-metals. Now you can see in the table positive ions and negative ions, that is hydrogen H plus, sodium Na plus, zinc 2 plus, that is it loses 2 electrons, and so on. And in the anion you can see chloride, bromide, fluoride, etc. So now you have understood what are radicals. Radicals are actually the charge, that is cation and anion. Now we shall revise the whole topic. Now we have seen till now that a compound is formed by ionic bond, that is molecule has two parts, cation and an anion, that is a basic radical and an acidic radical, and these two parts are oppositely charged. So the force of attraction between them constitutes the ionic bond. That means the name of an ionic compound has two words, that is cation and an anion. Now for example, we shall write the formula of a chemical formula of compound such as sodium sulfate. Now here the first step is you write the symbol of the cation on the left hand side, that is basic radical, and an anion on the right hand side, that is acidic radical. Now here you can see that here in sodium sulfate, sodium is cation. So hence that a basic radical is written on the left hand side, and the anion, that is sulfate, acidic radical, is written on the right hand side. Now the next step is you write down the valency of each radical. That is, for example, for instance here 1 is the valency of sodium, so you write 1 below sodium, and 2 is the valency of sulfate, so you write 2 below sulfate. Now the next step, that is third step, is you cross multiply with by the arrows the number of the radicals. So when you cross multiply, you get Na2 and SO4. So this is the chemical formula of the compound sodium sulfate. In this manner, you can write the chemical formulae of each compound. But always remember, to write the chemical formula of the compound, you should know the valency of the various radicals, as you have seen in the previous chart. Now in this slide, you can see writing how to write chemical formulae of different compounds. For example, calcium oxide, sodium nitrate, sodium carbonate, aluminum oxide, calcium hydroxide, ammonium sulfate, etc. So in this manner, you can write chemical formulae of different compounds. So thank you children. Hope so children, you have enjoyed and you have understood the topic well. Thank you children.